Hello everyone, welcome back. In the last video, we defined the derivative as a function, and we can use this function to determine the slopes of the tangent lines at various points along the curve. We also looked at defining higher order derivatives, so for example, the second, the third, or the nth derivative. And what we found was the calculations using the limit definitions can get quite repetitive and tedious. And so the goal of this chapter is to look at ways of simplifying our process of calculating the derivatives of functions without needing to use limits directly. And so we're going to develop some rules, and these rules will help us find the derivatives of the different types of functions that we introduced in the first chapter. And after we have learned these rules, we can then look at the applications of differentiation. So the first thing we'll cover are the derivatives of polynomials. So we'll first start by finding rules for the derivatives of power functions, and then rules for the derivatives of functions that are obtained by multiplying a function by a constant, as well as adding or subtracting a function. Now, the proofs of these rules will be in another video, and if you're a math major, or if you're interested in knowing where these rules come from, then I highly recommend that you watch this video. But the goal of this video is to focus on introducing the rules as well as applying them. So the first derivative rule that we'll learn is the derivative of a constant function. So if c is a constant, then the derivative of a constant is equal to 0. And so what this says is that if our function is a constant, which means that y is equal to c, where c is some real number, then its derivative is going to be 0. So that tells us that the slopes of the tangent lines along every point along the curve will always be 0. And so the derivative of the constant function is 0. The next rule gives us the differentiation rule for power functions. So this is called the power rule. If n is any real number, then the derivative of x to the power of n is n times x to the power of n minus 1. So the way that you can remember this rule is to multiply the exponent in front as a coefficient, and then we subtract 1 from the exponent. And so the power rule is n times x to the power of n minus 1. The next rule is called the constant multiple rule. If c is a constant and f is a differentiable function, then the derivative of c times f of x is equal to c times the derivative of f of x. So what it says is that if we want the derivative of a constant times a function, I can multiply that constant in front, and then I differentiate f of x. The next rule is called the sum rule. If f and g are both differentiable, then the derivative of f of x plus g of x is equal to the derivative of f plus the derivative of g. So if we want to differentiate the sum of two functions, then we can differentiate each functions separately and then add their derivatives together. A similar rule is called the difference rule. And if f and g are both differentiable, then the derivative of f of x minus g of x is the derivative of f minus the derivative of g. So the derivative of a difference of two functions is the difference of their derivatives. So we can differentiate f and g separately and then take their difference. So let's have a look at some examples. So for the first example, we have f of x is equal to 1. And we want to find the derivative of this function. Now 1 is a constant, and by the first rule, we know that the derivative of a constant is equal to 0. So f prime of x is 0. In the second example, we have f of x is equal to x. And so here we're dealing with a power function. So we're going to apply the power rule. And so x has an exponent of 1. And the power rule says that we multiply 1 in front, and then we subtract 1 from the exponent. So we have 1 minus 1. So that is 1 times x to the power of 0. And anything to the power of 0 is equal to 1. So we have 1 times 1, which gives us 1. And so the derivative of x is equal to 1. In the next example, we have f is equal to x squared. And again, we have a power function, so we apply the power rule. So we're going to multiply the exponent in front. So that is 2 times x, and then we subtract 1 from the exponent. So that gives us 2 times x. And so the derivative of x squared is 2x. In the next example, we have f is equal to the square root of x. So again, it's another power function. And if we're dealing with square roots, or any root in general, we want to rewrite the root as an exponent. So the square root of x can be written as x to the power of 1/2. And so we can apply the power rule where the exponent is 1/2. So the power rule says that we multiply the exponent in front. So we have 1/2 times x, and then we subtract 1 from the exponent. So we have x to the power of 1/2 minus 1. And 1/2 minus 1, well, we can make a common denominator of 2. So this is 1/2 minus 1 times 2 over 2. So 1/2 minus 2 over 2 gives us negative 1/2. And so we can simplify the derivative as 1/2 x to the power of negative 1/2. In the next example, we have f is equal to 1 over x, so the reciprocal function. And if you recall from the previous video, we determined that the derivative of 1 over x was negative 1 over x squared. And we use the limit definition to calculate our derivative. So now let's have a look at using the power rule instead. So we can rewrite 1 over x as a negative exponent. This is the same as x to the power of negative 1. So now we can apply the power rule where the exponent is negative 1. So we multiply the exponent in front. So we have negative 1 times x to the power of negative 1. And then we subtract 1 from the exponent. So this gives us negative 1 times x to the power of negative 2. And we can see that this can be written as negative 1 over x squared, which is the same as what we discovered from our last video. In the next example, we have f is 1 over x to the power of 2/3. And so once again, let's rewrite it so that it's a negative exponent. So this is the same as x to the negative 2/3. And then we can apply the power rule where the exponent is negative 2/3. So we multiply negative 2/3 in front, and then we subtract 1 from the exponent. So we have negative 2/3 minus 1. So let's simplify the power. So negative 2/3 minus 1 will make a common denominator of 3. So that's negative 2/3 minus 3 over 3, which is negative 5/3. So this is negative 2/3 times x to the power of negative 5/3. In the next example, we have f is x to the power of pi. So here we are dealing with another power function where the power is pi. And we know that pi is a constant. And so we treat it just like any other constant. So we apply the power rule. We will multiply the exponent in front, which is pi, and then we subtract 1 from the exponent. So we have x to the power of pi minus 1, and this is as simplified as we can get. So our derivative is pi times x to the power of pi minus 1. So for h, we have f is x cubed minus 2x squared plus 3x plus 1. So we have a polynomial. So now we can use the other rules to differentiate this function. So we're going to differentiate each term separately and then add them all together. So let's have a look at f prime of x. So the derivative of x cubed, we'll apply the power rule. So we multiply the exponent in front, which is 3, and then we subtract 1 from the exponent. So 3 minus 1 is 2. So we have 3x squared. Now we have minus 2x squared. So again, we will apply the power rule. We will multiply the power of 2 in front. So that's negative 2 times 2, which gives us negative 4. And then we subtract 1 from the exponent. So 2 minus 1 is 1. And so we're left with a power of 1. So we have negative 4x. Then we have plus 3x. And the derivative of plus 3x, we know that the derivative of x is equal to 1. So that is plus 3 times 1. And then the derivative of plus 1, so the derivative of 1 is equal to 0. So we can simplify this to 3x squared minus 4x plus 3. In the next example, we have f is x to the 3 halves minus 2x to the 1 half plus x to the negative 1 half. So here we're dealing with more power functions. So again, let's apply the power rule to each term separately. So the derivative is 3 over 2 times x to the power of 3 over 2 minus 1. So if you want to do this to the aside, 3 over 2 minus 1 is 3 over 2 minus 2 over 2, or is 1 half. So we have 3 over 2 times x to the 1 half minus 2 times, now we apply the power rule to 1 half, so that is 1 half times x to the power of 1 half minus 1, which we know to be negative 1 half, and then the last term we have x to the negative 1 half, so we multiply the exponent in front, which is negative 1 half, and then we subtract 1 from the exponent. So negative 1 half minus 1 is negative 1 half minus 2 over 2, or negative 3 halves. So this is x to the power of negative 3 halves. And now we can simplify our derivative. So we have 3 over 2 times x to the 1 half. We have negative 2 times 1 half, which is negative 1. So that is negative x to the negative 1 half. And then we have minus 1 half x to the negative 3 over 2. In the next example, we have f is x to the power of e minus pi x squared plus 5x to the 1/3 plus the natural log of 2. Okay, so now we're dealing with an algebraic function. So let's apply the power rule appropriately. So the derivative of x to the power of e, so e is our constant, so we will multiply the exponent in front. We have e times x to the power of e minus 1. We have negative pi times x squared, so we multiply the exponent of 2 in front, so that is minus 2 pi, and then we subtract 1 from the exponent, which leaves us with an x. Then we have plus 5 times 1/3. We multiply the 1/3 in front, and then we subtract 1 from the exponent. So 1/3 minus 1 is negative 2/3. And then we add it to the natural log of 2, or the derivative of the natural log of 2. And the natural log of 2 is a constant. And we know that the derivative of a constant is 0. So we add 0 at the very end. And now we can simplify this slightly. We have e times x to the power of e minus 1 minus 2 pi x plus 5/3 x to the negative 2/3. In the next example, we have f is 2 times x to the natural log of 3 plus pi squared minus 5 times the root of x cubed plus 2 to the power of 40. All right, so now before we apply our derivative rules, let's simplify. Let's rewrite the fifth root as an exponent. So we have 2 times the natural log of 3 plus pi squared minus x to the power of 3 over 5. So now we can apply our rules of derivatives. So we will multiply the exponent in front. So 2 times the natural log of 3 times x to the power of the natural log of 3 minus 1. Now pi squared is a constant, and so the derivative of a constant is 0. So we add plus 0. Then we minus the derivative of x to the 3 fifths, that's 3 over 5, times x to the power of 3 over 5 minus 1. And 3 over 5 minus 1 is negative 2 fifths. And then the derivative of 2 to the power of 40, well, that is also a constant, and so its derivative is 0. And so our derivative will be 2 times the natural log of 3 times x to the natural log of 3 minus 1 minus 3 over 5 times x to the power of 2 over 5. In the next example, we have y is equal to the cubed root of x times 2 plus x. So let's first rewrite the cubed root of x. This is x to the power of 1/3 times 2 plus x. And now let's also simplify by distributing the x to the 1/3 through the brackets. So this is 2 times x to the 1/3 plus x to the 1/3 times x is x to the power of 1/3 plus 1, which is 4/3. So now we can take the derivative. So we apply the power rule. We have 2 times 1/3 times x to the power of 1/3 minus 1, which is negative 2/3, plus 4/3 times x to the power of 4/3 minus 1, which will be 1/3. So we can simplify this to 2/3 times x to the negative 2/3 plus 4/3 times x to the 1/3. And for the last example, we have y is the root of x plus x all over x squared. So let's first rewrite our square root of x. This is x to the 1/2 plus x all over x squared. And now let's simplify this fraction. So let's split it up into two fractions. We have x to the 1/2 over x squared plus x over x squared. And if we use the law of exponents, we can simplify this by subtracting the exponents. So x to the 1/2 over x squared is x to the 1/2 minus 2. And the last term, we have x over x squared. So that is x to the power of 1 minus 2. And now simplifying, we have 1/2 minus 2, or 1/2 minus 4 over 2, which is negative 3 over 2. And we have x to the power of negative 1. And now we can apply our power rule to this function. So y prime is negative 3 over 2 times x to the negative 3 over 2 minus 1, which is negative 5 over 2. Then we have minus 1 times x to the power of negative 1 minus 1, which is negative 2. And so that is our derivative.